While here, we change u, which is still the same thing as x. But what we keep constant is v, or in terms of x and y, that's y minus x constant. And that's why they're not the same. So whenever there's any risk of confusion, okay, so not in the cases that we had before, because, in what we've done until now, we didn't really have any problem. But in a situation like this, to clarify things, we'll actually say explicitly what it is that we want to keep constant. Okay, so what's going to be our new notation? Well, so it's not particularly pleasant because it uses now a subscript not to indicate what you're differentiating, but rather what you're holding constant. So that's quite a conflict of notation with what we had before. I think I can safely blame it on physicists or chemists. So, okay, so this one means we keep y constant. And partial f over partial u with v held constant similarly. Okay, so now what happens is we no longer have any contradiction. We have partial f over partial x with y constant is different from partial f over partial x with v constant, which is the same as partial f over partial u with v constant. Okay, so this guy is 1, and these guys are 2. So now we can safely use the fact that x equals u if we are keeping track of what is actually held constant. Okay? So now that's going to be particularly important when we have variables that are related. Because let's say now that I have a function that depends on x, y, and z, but x, y, and z are related. Then it means that, if I look at, say, x and y as my independent variables, and z as a function of x and y, then it means that when I do partials, say, with respect to x, I will hold y constant, but I will let z vary as a function of x and y. Or I could do it the other way around. I could vary x, keep z constant, and let y be a function of x and z. And so I will need to use this kind of notation to indicate which one I mean. Okay. Any questions? No? All right. So let's try to do an example where we have a function that depends on variables that are related. Okay, so I don't want to do one with PV equals nRT because probably, if you've seen it, then you've seen too much of it. And if you haven't seen it, then maybe it's not the best example. So let's do a geometric example. Okay, so let's look at the area of a triangle. So let's say I have a triangle, and my variables will be the sides A and B, and the angle here, theta. Okay, so what's the area of this triangle? Well, it's base times height over 2, so it's 1/2 of the base is A, and the height is B sine theta. Okay, so that's a function of A, B, and theta. Now, let's say actually there's a relation between A, B, and theta that I didn't tell you about. Namely, I want to assume that it's a right triangle. Okay, so let's now assume it's a right triangle with, let's say, the hypotenuse is B. So we have a right angle here, actually. So A is here, B is here, theta is here. So saying that it's a right triangle is the same thing as saying that A equals B cosine theta. Okay, so that's our constraint. That's the relation between A, B, and theta. And this is a function of A, B, and theta. And let's say that we want to understand how the area depends on theta. Okay, what's the rate of change of the area of this triangle with respect to theta? So I claim there's various answers. I can think of at least 3 possible answers. So what can we possibly mean by the rate of change of A with respect to theta? So these are all things that we might want to call partial A, partial theta, but of course we'll have to actually use different notations to, distinguish them. So the first way that we actually already know about is if we just forget about the fact that the variables are related. Okay? So if we just think of little a, b, and theta as independent variables, and we just change theta, keeping a and b constant. So that's exactly what we meant by partial A, partial theta, right? We are not putting any constraint. So just to use some new notation, that would be the rate of change of A with respect to theta, keeping A and B fixed at the same time. Of course, if we are keeping A and B fixed and we are changing theta, it means we completely ignore this property of being a right triangle. So in fact, it corresponds to changing the area by changing the angle, keeping this length fixed, and of course we lose the right angle.